Alright, you guys. Probability of multiple events. Dependent events, independent events. Dependent events are when the first event affects the outcome of the second event. They're dependent of it. You're basically doing two things. You're pulling out two cards out of a deck. When you pull out two cards out of a deck, doesn't the second card get affected by the first card? Because once you pull out one, isn't the second one have less cards to choose from? So, when you're talking about dependent events, you're talking about, like, for instance, drawing two cards from a deck of cards. That's like drawing two cards from a deck of cards. You have two events. For instance, the first one you might have a probability of, for instance, say 4 out of 52. But the second one, you have 51 cards left over. And depending on what you're grabbing for, you might say you want two aces. The first one's 4 out of 52. The second one will be 3 out of 51 if you want two aces. Because the second one depends on the first one. Now, independent events mean the first event does not affect the outcome of the second event. Alright? What that means is replacement. This means there's something called replacement. You're putting it back into the deck. Got it? Replacement, you're either putting it back into the deck or it doesn't. Another example would be rolling dice. If you roll the dice, the second time you roll the dice, does it affect the first?
No.
Okay. Flipping a coin. If you flip a coin a whole bunch of times, does each time you flip a coin affect the next one? No. So examples of these would be rolling dice or flipping a coin. So, because what happens here is it doesn't affect. For instance, if I flip a coin, flipping a coin, wouldn't it be like 1/2 each time? Do they not affect each other? If you roll a dice, doesn't each time not affect it? You just keep multiplying them together? Okay. So that's the first thing. Now, first of all, also, when you have independent and dependent events, here's what happens. It's an and. I have first event and second event. And what you do when there's an and is you multiply the two events. Here, nothing changed. Here, you have to change the second one because it depended on what you got the first one. Next, mutually exclusive, not mutually exclusive. What do you see in this word right here? What's right here? Or. And what do ors have? Plus. Isn't this one also an or? Now, there's a difference between mutually exclusive and not mutually exclusive. Mutually exclusive events are two events cannot happen at the same time. Meaning, an example of that is if you're looking at a deck of cards, I want the probability of a spade or a heart. Now, if you know cards, could you draw a card that's a spade and a heart? No. They don't overlap, do they? The probability of a spade or a heart, well, that would be, what's the probability of a spade? Well, there's 1/4 of the deck. Plus, what's the probability of a heart? Would that be another 1/4? So would it be, you add those up, 2/4, 1/2. The probability of a spade or a heart is 1/2. Because these do not overlap. They are mutually exclusive. The two events cannot happen at the same time. We cannot have both these things happening at the same time with one card. The difference, this is one thing. These were two events. This is one event. Multiple characteristics. Here, not mutually exclusive means two events can happen at the same time. For instance, this would be the probability of a black or an ace. Can you have a black card? Can you also have an ace? Can you also have black aces?
Right.
Can these both happen at the same time?
Mm-hmm.
Yeah. So there's a problem here. It's called not mutually exclusive. And so what happens here is you take probability of both of them, but then you have to subtract where they share. Just see in a second. For instance, what's the probability of black? Well, how many cards are black in a deck? Aren't half of them? So half the cards in a deck are black. Plus, what probability of the cards in a deck are aces? Half the cards are black. How many are aces? 1 out of 13. Minus the probability of black and aces. So that one's a little bit different. And, don't you multiply? So what's the probability of black? Times. Do you guys remember? We just did it earlier. And is multiply. So what you do is you add these two but subtract the and of both of them. Basically that gets rid of when you double count. Because if you counted these black cards and then you counted aces, aren't there two black aces that you counted twice? Don't you have to take out those two black aces that you can't count them twice. It's kind of like repeating itself. So, yeah, that's basically the scoop of this topic.